De Morgan's law states that the negation of a conjunction is a disjunction, and vice versa. The negation of a disjunction is a conjunction. We can very easily prove that by making truth tables for these statements and showing that the columns will be identical. This is a very, very important theorem, and you should take some time to try to memorize it and learn it, or be able to come up with it on the spot when you need it. Let's try to use De Morgan's law to negate the following statements. Pause the video here and see if you can try to figure out the solution to these problems. First problem says John is 6 feet tall and he weighs at least 200 pounds. The negation for that first would need to have the tilde in front of it. So the tilde parentheses means that we're negating the expression or the statement. And the negation would be John is not 6 feet tall, or he does not weigh at least 200 pounds. So we had started originally with an and statement. The negation of it becomes an or statement. We also have to negate the two components before and after the or. This is the reason why we're putting not 6 feet tall, and also we're putting not, he does not weigh at least 200 pounds. Now, the second example says the bus was late or Tom's watch was slow. This is an example of a disjunction. So to negate the disjunction, we have to write an and statement, a conjunction basically. And we also have to negate both sides of the conjunction. We have to say that the bus was not late and Tom's watch was not slow. Keep in mind that if you try to simplify these expressions, you may run into problems very quickly. So like for instance, you cannot replace the words not late with early. What's the reason for that? Well, the bus was not late. That means it could have been on time or it could have been early. We don't know which one is true, so that's the reason why we don't want to simplify the expression there. We would rather leave it as the bus was not late. Similarly, saying that the watch was not slow does not mean that it was running fast. It could have been also on time. So again, we don't want to run into those problems where we simplify it. So for now, we're going to leave it as Tom's watch was not slow. Finally, we have a compound inequality saying -1 less than x less than or equal to 4. So how would we go about negating this? So again, we have to keep in mind that -1 less than x less than or equal to 4 is an example of an and statement. So to negate it, we have to negate both sides and put an or. And you can see the process of the negation in the next few steps. Ultimately, the negation of -1 less than x less than or equal to 4 is the same thing as x less than or equal to -1 or x is greater than 4. So we can see that if we draw a real number line and we have -1 and we have 4, in the first part of the problem we were saying that x is supposed to be between those two, not including -1, so parentheses there, and a bracket on 4 because x could include that. So x was supposed to be in this section of the real number line. Now if you're saying x is not there, then x is going to be in the first part of the number line, including -1, or the second part of the number line, excluding 4. So this is saying x is less than or equal to -1, or x comes from the second part of the number line where x is greater than 4, but not itself equal to 4. So doing it logically using the symbols that we're learning in this chapter and using algebra results in the same expression at the very end. That's good. That means the logic is matching with our algebra.